Welcome to AI-generated Stuff channel, where we break down complex topics into easy-to-understand videos. Today we're diving into the quick sort algorithm. Quick sort is a highly efficient sorting algorithm used to organize lists or arrays. It works on the divide and conquer principle, splitting the original data into smaller parts to solve the problem. By selecting a pivot element from the array, quick sort partitions the other elements into two subarrays, according to whether they are less than or greater than the pivot. These subarrays are then sorted recursively. This method significantly reduces the time complexity, making quicksort one of the fastest sorting algorithms available, especially for large datasets. Its average case performance is O(n) log n, which is quite impressive. To begin, quicksort selects a pivot element from the array. This pivot can be chosen in various ways, such as picking the first element, the last element, or even a random element. The choice of pivot can affect the efficiency of the sort, but the fundamental process remains the same. The goal is to reposition this pivot so that elements less than the pivot come before it and elements greater come after it. This step is crucial, as it sets the stage for the sorting process. By doing this, we ensure that the pivot is in its final sorted position. This process is called partitioning. During partitioning, elements are compared to the pivot and swapped accordingly to ensure that the array is divided correctly. This might involve multiple swaps and comparisons, but the end result is a partitioned array. Once the pivot is in the correct place, the array is divided into two halves around the pivot. These two halves are not necessarily equal in size, but each half will be independently sorted in the next steps. Quicksort then recursively sorts the two halves, applying the same logic of selecting a pivot and partitioning the subarrays. This recursive approach continues until each subarray contains only one element, at which point the array is fully sorted. The beauty of quicksort lies in its divide and conquer strategy, which efficiently breaks down the problem into smaller, more manageable parts. Let's watch a quick example of the quicksort algorithm in action. Here, the number 5 is chosen as our pivot element. Notice how elements are rearranged around it, with smaller numbers moving to the left and larger numbers moving to the right. Once the number 5 is correctly positioned in its sorted place, the process repeats for the left and right subarrays. This recursive partitioning continues until the entire array is sorted. Quicksort is efficient and widely used due to its average case time complexity of O(n) log n. Now, let's see it in more detail. Compared to other sorting algorithms like merge sort and bubble sort, quicksort is generally faster, though its performance depends heavily on the choice of the pivot. Quicksort is particularly effective for large datasets and is often preferred in scenarios requiring efficient, reliable sorting. Thanks for watching. Like this video if you learned something new, and subscribe for more insights. See you next time.